Well, Merry Christmas 2022, everybody. Welcome to idea video number 8. It's been a long time, several years actually, since I did a previous video on Aquarium. So if you're not an Aquarium user, this video is not for you. And if you don't have more than one computer in the whole wide world, this video is not for you. But if you are an Aquarium user and you do have one or two spare machines lying around your house, or even more than that, you definitely want to watch this video because I can show you how to link them all together to build a super powerful network of computers to do analysis faster. That is what today's video is all about. I know Aquarium is not developed anymore, but it is still my preferred software of choice for chess analysis, especially for opening chess analysis, because it has some very unique features which no other piece of chess software has. And today's video is covering one of those unique features, the ability to harness a vast amount of compute power that you may already have lying around. You just didn't consider using it before. Also, for those people who work in an office or a hospital perhaps, or a school or a university where there's loads of computers lying around, particularly at night time, they're not doing anything. If you can get permission to get access to those machines, you could potentially build yourself a vast network with compute power many times greater than you would get from one machine. Aquarium can do that within reason, and certainly I've had well over 100 physical cores analyzing it once to build up a tree of analysis. Now, I know there is a considerable debate going on at the moment about how much compute power you actually need, because with today's chess engines being so strong, you can get excellent results on even a laptop. But that's not really what we're talking about today, because today we're not just talking about analyzing one position, like a middle game position. We're building up a tree of positions so that you can answer huge questions like, what are the pros and cons of the Grunfeld defense versus the King's Indian? Now, that is a very difficult question to answer if you've only got a laptop and you're going backwards and forwards using infinite analysis. You'll be there for a very long time trying to work out where the critical lines are and how various novelties have impacted the evaluation of those lines down the years. You really need a tree built up for you to get a much quicker overview of the two defences. And of course, other openings would be very similar to that. My own opening repertoire is currently, the tree has currently got about 350,000 positions in it. It took months to build up. Obviously, 99% of those positions are irrelevant to me, but that doesn't matter because you use the giant tree as an overview just to get a sense of where the critical lines lie. Now, you do need some equipment for this. You need to have one Windows computer running Aquarium. That's a must. And you need to have a spare computer to be able to network to it. If you haven't got that, we can't proceed any further. There's also some software which you almost certainly won't have, which you will need to download, but I'll come to that later on. And you want the two computers that you want to connect to be on the same network. So I know it's theoretically possible to do what I'm doing today with computers on the other side of the city or the other side of the planet even, but to keep it simple, I think you should probably have them in the same, ideally in the same room, and connected to the same router, just so that we make it simple stupid today, to borrow an army expression. The benefit of what I'm going to show you is that you can raise a huge amount of compute power in the long run. Today we're going to have a very low aim, which is just to connect one single core from an external machine to your current machine running Aquarium. That's what we're going to achieve today. If you want to add more cores later on, it's really simple. You just repeat the process. You repeat the same process again and again and again with each additional core on each additional computer that you want to add to your network. And you can build this up and up and up, and I've added well over 100 physical cores to a network, and Aquarium seems to be able to cope pretty well. So that's the aim for today. I hope it's worth it. do sit back and enjoy. And just so we get things really clear, this is a video you're going to want to go through slowly. Don't rush it, because the steps can be a bit technical if you're not a IT type of a person. If you're quite sort of if you're more at the beginner stages of IT and you've never seen any programming code before, you might be a little bit daunted, but just go slowly. If you are a dab hand and you're used to working with scripts and so on, you'll fly through this in no time whatsoever. But enjoy, and Merry Christmas 2022.
Step 1. Get some pizza.
Well, strictly speaking, this first step isn't necessary at all, but I found it really helps because it will slow you down, and every time you complete a step, you can celebrate by taking a munch of pizza.
Step 2. Choose one computer to be the master and one to be the slave.
When it comes to choosing which computer you want as the master and which one as the slave, I strongly advise you choose your biggest, best machine to be the master. And usually that means the one with the most physical cores, and then choose the smaller machine to be the slave. The reason is that if you do it the other way round, you'll end up adding a huge number of cores to your network, whereas they would already be added if they're on the master, because the master computer will be running Aquarium, the slave computers will not. In this case, I've got two computers. You can probably tell which one is more powerful. This is a workstation class machine. It's got 12 cores. This one is a fairly puny dual core computer, and this one, it has got 1/6 the number of cores, and also the cores are running more slowly than this one. So I'm going to make this computer the master computer, and then this one is going to be the slave, and I'm going to add one of those two cores to this computer. And what I'll then do is, once this video is over, I'll repeat the process to add the second core, but you can do that for yourself in your own time.
Step 3. Make sure both computers are connected to the same LAN via Ethernet.
Just to keep things simple, for this first attempt you do this, make sure the master and the slave both have Ethernet cables going into the same switch or router to avoid problems.
Step 4. On the slave, create an empty folder called Remote Engine.
So this is my slave computer. It's got 2 hard disks, and on the C drive I'm going to create a new folder called Temp Dump. This is where I like to store things that are going to be here just for a short period of time, and within that folder I'm going to create another folder called Remote Engine, and that new folder, Remote Engine, is going to be the receptacle for everything that we're going to stick in it.
Step 5. Download RTHomeServer on the slave.
Go to the download link at the bottom of this video and click on that one there and download RTHomeServer. It really is a magical little piece of software that's not very well known and very difficult to find. So I suggest you download it and keep it somewhere safe for future use, and then make a copy of it that you will use for this project. What we're going to do is we're going to go back to that folder we created just now, Remote Engine, and just dump it all in there. To extract it, you'll need a piece of software called 7-zip. Get hold of that, extract it, and then it's all there, and it should look exactly like that.
Step 6. Download the engine you want to use on the slave.
The crucial thing is that you use the same engine all the way through your project. So you want the same engine running on the master and the slave and every single core you add to your network. Don't have different engines running in your analysis, because it'll just mangle everything. So you want to stick it all into the Remote Engine folder. You'll need to extract it as before, and then you just want the Stockfish engine. So what I'm going to do is going to take that out, put it into the Remote Engine folder, and then I'm going to clean up a little bit so I get rid of the redundant files and folders just to make it all a bit neater. So by the time you finish, it should look like that.
Step 7. On slave, open command prompt and type ipconfig.
Computers have addresses just like your home has an address, but it's a digital address. To find it, open up a piece of software called Command Prompt. You can type it into Windows to get it up there. It looks like a old DOS box. Comes up and you type in ipconfig and that produces a list of bewildering numbers, but the one you need to take note of is that. So it's next to IP4. So just make a note of it and don't forget it.
Step 8. Take note of the IP4 address on the slave. Step 9. Edit the RTHomeServer configuration file.
Right, just before we open up the configuration file, what I've done here is I've cut and pasted the configuration file into a word processor just so you can see what it looks like, and that will allow us to see things a bit more clearly and we can go a bit more slowly and just walk through it, because this is probably the most difficult part of the video. Now, if you've never seen a script like this before, it potentially is quite daunting. What I recommend is just leave everything exactly as it is. Don't touch a thing, with the exception of the 3 values that I have highlighted there in pink and yellow. Those are the only 3 you want to touch, and you want to make sure you get the right hash and the right CPU value, because there's 2 of them listed. Just above you'll see hash and CPU, don't touch those. So leave everything the same, but you're going to make the hash what you think is suitable for your computer. So on your slave PC, you've got to work out how many engines do I anticipate adding, and then you need to make sure you've got an appropriate amount of RAM to do that. So let me give a quick example so it's clear. If you've got an 8-core slave PC and you wanted to make the hash value 1024, which is a good value, that's what I make it, that's one gigabyte of hash for each engine. And if you're going to do that 8 times over, because you're going to add 8 engines effectively, because you've got an 8-core PC, that means you need to have enough RAM in your computer to do that, which would be, in this case, you'd need 8 gigabytes, even though each engine is only 1, because there's 8 of them. And then you'd probably want the same again for Windows, because you typically don't want the hash value to go above 50% of the RAM value. So that would mean you would want 16 gigabytes of RAM in your computer, quite a bit. So don't go nuts on the hash value. You might want to set it below 1 gigabyte. It depends how many times you're going to add an engine. On the Mac CPUs, because we're adding engines into Aquarium, you just want the Mac CPU set to 1, because each new engine is going to run on its own core, so you only want a 1-core engine. If you were adding an analysis engine into Sandbox, you might want to set the CPU value to the same number as the number of cores you've got, because you'd only be adding 1 instance, but that's not what we're doing here. We're adding an Aquarium IDEA engine, and therefore we want each engine to have its own core, so therefore I set the CPU value to 1. Now the port number is defaulted at 7788. Leave it at that for the first time, but every additional engine you add, you're going to add 1 to that number. So the next one will be 7789. After that, 7790, and so forth. And you can add loads of them, but make sure each engine has got its own port number, and that way you won't get any conflicts. Okay, I'm going to close this down now, and then we'll move on to the actual configuration file, which I'll open up and edit normally. Okay, so we're going to open up the file. You are going to use a piece of software called Notepad. That's included in Windows. So just open it like this, get yourself orientated, and then scroll down to the relevant place. So there we notice the port number 7788, so that's correct. And now we need to start editing our values. So the hash is the one I want to change, and that will be 1024, 1 gigabyte. Leave the CPU at 1. Leave the port at 7788 this time. File, don't forget to press save, crucial, and then close it down.
Step 10. Start RTHomeServer.
Okay, now you've edited that configuration file, you're actually going to click on RTHomeServer and start it up. It'll come up with an error message because it can't find the engine that you want to start. That's okay. Just take note of all the values that they match and then find your engine that we added into the remote folder, which is Stockfish in my case, and check all the values are all right, the port number matches, hash, everything. Then it'll come up with a firewall warning. That's all right, just allow access because it should be all running on your home network and you are good to go. That is actually running now.
Step 11. Eat pizza.
Yeah, we're basically at the halfway stage, so we won't be doing any more work on the slave machine, and therefore this is a great time, if you've successfully completed all of these steps so far, to have a little celebration and munch into that pizza.
Step 12. Move to the master computer and check Aquarium is installed and running OK. Step 13. Add remote UCI engine.
So now we want to add the engine to Aquarium on the master. Click on the engine tab on the left, click on the green plus at the top, and then go to add remote UCI and then name your engine something. Check everything matches, the IP config address, the port number, you name it, check the name's okay. And if it's working properly, when you click on the left thing on the side, it should go to a green tick immediately. Check the priorities, the hash, the thread value, check it all matches, and then you're done.
Step 14. Check it's working properly in Sandbox.
Okay, don't add the new engine to your idea project just yet. Let's get it going in Sandbox just to test it. So click on the analysis and find that engine, press start, and it should come up immediately with analysis. Notice that the nodes per second isn't super high because we're only running on a single core, but if it looks something like that, it's working perfectly.
Step 15. Add remote engine to IDEA, remembering to adjust speed settings.
Now move over to IDEA, click on that, click on your project, click on engines, scroll to the bottom, click add, find your new engine, add it into the project, and then adjust the speed settings. My slave computer is about 10% slower on each core than the master, so I'm going to raise that by 10% to give it more thinking time.
Add more cores and more computers until you've got a seriously fast cluster. Step 16. Sit back and cackle like a lunatic.
Before you go and build your super duper cluster to take over the world, here are some tricks and tips to get you started on the right track. First of all, you need to get control of Windows updates. Do not underestimate Microsoft's determination to force updates onto your PC. I have lost count of the number of times I've had a PC do a restart in the middle of the night while I was sleeping, only to wake up the next morning and find the whole project is completely messed up or nothing's working. It's really, really irritating, and the only way around it is to go into those update settings, to postpone updates for, I think they give you only 1 week of grace period, which isn't very long at all. And then every 6 days, so less than 7, you want to install new updates, restart the PCs, and then click postpone again so that you don't get hassled. I know if you go into the registry, you can delay it a bit longer than that, but I don't think you can put them off indefinitely. And they are a real nuisance. You just have to get organized and get on top of them. And the more computers you add, the worse it gets, because there's more PCs to juggle, there's more potential updates to slip through. And I'm afraid constant vigilance is the only way forwards here. Secondly, if you're going to use a large number of cores, which you'll add to your network, you may find that the Aquarium software begins to struggle. This will be particularly true if you're running things at a relatively short time control, where each engine only has a minute or less to think. It gets a bit easier if you give it more time, but certainly if you get over 50 cores, you may find the back end of Aquarium begins to struggle. And I was really gutted when I heard about this. Somebody said online, oh, you can't go over a certain limit. But I have found a bit of a workaround. The way to do it is to set the cores off in batches. So set them off in groups of 20 or something. And that way they're not all trying to start at once, and they're not all dumping their analysis onto Aquarium at the end at once. What you want is lots and lots of cores to start higgledy-piggledy out of order. And that way the Aquarium software backend doesn't get overwhelmed. Finally, don't forget to back everything up really regularly. Disaster can strike. People can hack into your computer. It might get a virus. Who knows what might happen? The tree could get corrupted. Make sure you've got regular backups. Don't leave it months and months. Otherwise, all that analysis could be wasted. And when you've finally done your project, or you've got it to a good state, don't forget that you can take it with you on a slow laptop, and even a slow laptop can open up an Aquarium project and run it really fast. You'll have a massive advantage over everyone else in the tournament. Have fun and see you next time.